Let me make sure that does say it's recording. Yeah, okay. Oh, no, they didn't give me my equipment in time, so they don't get thanked. I had to plug in a lot of things. All right, so the way I found Python was because at the time I was just starting to dabble in programming, and I had things I wanted to do that were a pain in Excel macros, but basically I wanted to be able to combine spreadsheets, or I wanted to pivot spreadsheets, or do all sorts of things to spreadsheets. And I knew that in general, learning to program could help me automate that and save a script and be able to just click run every day. So we had this thing where we would have like a daily log where it would be each transaction was in the log file. But what I needed to do was basically, if they were in the log file, then whatever they used to be, I just wanted to flip them to registered on the contact object in Salesforce, which meant I needed one record per person and a bunch of fields going across the side with the word registered in them so that I could upsert that data into Salesforce. And so that's a pretty common pivoty type of operation, but I needed to do it every single day. And so I wanted that particular part of it to be fast. In fact, I even ended up combining that script with simple Salesforce to make sure that I could then pull down all 70,000 contacts and try to match them on name and email so that I could actually have Salesforce IDs ready to go and truly do an upsert operation. And I ended up also building a small web user interface on Heroku to make it so that somebody else could take that spreadsheet and punch it in, and I could just teach them how to do it. So that was, and Python was the language I used to write that small web server in. So that was getting way advanced, but that's an idea of how Python, if you really decide like, I'm gonna be a programmer, I love programming, you can really start to integrate things that you're doing today with stuff that's more traditional programming. But even had I just been doing this, literally just having to pivot this every day would have been annoying in Excel. And I could just hit run if I just saved my steps, just like in an Excel macro, but I didn't like the way you write macros. This felt unpleasant to write, particularly because what I needed to do was do things like look for whether a certain piece of information started with the word status, for example. And if it did, just take all the column, actually maybe not so much this, but yeah, I needed to sort of be able to parse the idea of columns by their name, not by, that's column D. And Excel macros aren't always the best cutout for that. And Python with its Pandas plugin really, really is wonderful for that. That said, I haven't thrown Excel overboard. There are a lot of things that you'll learn today that you'll walk out of here thinking, that took a lot longer than it would have taken me to just do the job in Excel. And that's okay. I very often flip back and forth between the two, like literally in the same moment. I'll copy something off of Excel, paste it into Python, do the thing that is annoying in Excel, copy that, paste it back into Excel, if that's what I think is faster. So we're gonna do things the hard way today to build up skills, but there's never anything wrong with just saying, I don't like this tool. We're just adding a new tool to your tool bench. So we talked a little bit about things that you wish you could do, but I mean, specifically, I'd love like a volunteer or two to say, do you have a business problem that you thought of when you saw the description for this class? You're like, God, that would be so great if I could just write a script to do that. I got candy. Okay.
So a concrete business problem that I encounter is assessment results, and those come down daily during a testing window, or in sometimes batch file from the state once a year, and you can match those on an ID and then upload those.
Okay.
And right now, I handle that with a script on an automated basis, but it's data which is before.
Oh. Okay, yes. I don't know if we're going to get all the way through basically doing VLOOKUP today. I'm going to at least show you, and I'm going to have it in the slides so that if you want to play with it at home, you can. But yes, that's definitely one of the big things. You know, as I said, I'm matching on name and email, and it looks like we've got, we often change values according to specific logic for hundreds of thousands or millions of records. Yes, it can be very crashy in Excel, because the thing is, Excel is trying to, especially if you need to filter it, Excel needs to redraw all the rows on your screen. And that kind of redrawing on your screen, taking all those pixels, that is so much work for a computer compared to what you actually want to do data-wise. And so the great thing about Python, the terrible thing about Python when you're starting is that you can't actually see what's going on. The great thing about Python is it's not going to bother to show you what's going on, so it can just do the meat of the work. And it can crunch through really, really big data sets way faster. All right, so today we're all going to pull up an online IDE, which stands for Integrated Development Environment, and that can be a lot of things to programmers that help them do their jobs. But what I like to think of it as for beginning programmers is a text editor that sometimes has color highlighting about what the different parts of your code are, and that has a run button. So you get to type and you get to hit run, and then it's got a little window where you can see what it does if the code you wrote included commands to see what's here. Hello, welcome. Yeah, welcome. And so we're also going to do a lot of theory today. There's going to be some hands-on. I think I have a good 20 hands-on, very small problems that we will go through as far as sample code. But I'm going to do a lot of 101 type of introduction. This is kind of going to be computer science 101, and it's going to be a lot. There's going to be a lot of code on the screen. When we're doing the hands-on, if you can't type fast enough, you're finding that you're just like, I did not get that to work. Certainly, we have lab assistants. We have me. We can slow down. We don't have to get through the end of these slides. But at the same time, if you feel like, no, that's cool, whatever. What I really want to make sure is that you just felt like you've seen this before. If you Google it later, you'll say, oh, yeah, that when you see like .max parentheses, you're like, oh, yeah, that sort of makes sense that would do a maximum. So getting this idea of the concepts that when I say, okay, we're going to take this chunk of code that represents a column from our spreadsheet, and we're going to do .max, we're checking for the maximum of all those values. And so just getting that familiarity with having seen it once before, that's my number one goal. And so I definitely want to do a Python for Salesforce 102 in the future. And we'll do some more hard problems, maybe even a 103 if we need to. What I'd really like to do is take problems like yours and have everybody who has a problem like bring sample data, and we'll like hands-on together, we will solve that problem. So that's my ultimate goal for this class. I'm Katie. Welcome. Hi. What are your names? Maggie.
Lisa.
Hi, Lisa. Thanks for coming. So yeah, you haven't missed much. Just that I found Python by doing things like I needed to pivot data every single day, and that was tedious. And I wanted to write a script for it. And one thing I forgot to say is that I picked Python not just because it's a very simple language to write compared to other programming languages, but also because there was something called WinPython that I could install on my computer that would let me run it without having to tell the IT department that I was installing it on my computer. So that was the number one way I actually fell into Python. That's true. The documentation itself, I mean, it's not quite as easy as reading Salesforce documentation, but if you've ever looked at maybe the documentation for Salesforce of like the fields available for Apex, like the operations available in Apex code for the contact record, or for S-object, or various, or if you've ever tried coding in Apex, it's probably more like at the level of documentation that Salesforce puts out for that. But it's very well organized. And then there are wonderful people, like there are a couple of blogs. One is written by Chris Moffett, right here in the Twin Cities, Practical Business Python. And you're gonna love that one, because that's like particularly geared at statisticians and data analysts. And another one is Real Python, I wanna say .com, I just found it. And they jump all over the map. They do really hard programmery stuff, but every once in a while they'll say, here's how to split a piece of text apart. And they'll do an entire article on that. So very nicely done.
Any Python problem, if you just Google Python, how do I do this? The number one website that's going to come up is called Stack Exchange.
Yeah. And Stack Exchange is an interesting experience because they have a voting system for, they try to curate and make sure that the questions are well written so that when people Google it, they understand them. Which means that sometimes if you're new, people will downvote your questions because you're not used to the culture of what people think of as a good question. The thing is, you can always create a new account. So if you get downvoted so much that you can't create questions anymore, just start over with a different email address and try again.
Posting yourself can be dicey, but if you find people that post your question, then it's usually okay.
Yeah, there'll be a lot of examples. And eventually, I now have a Stack Overflow reputation of like 400, which is fine. I can get downvoted a lot before I can't post questions anymore. So eventually you get there. Also, there's a Salesforce Stack Overflow where people are a little friendlier about upvoting, so you can boost your reputation there. Okay, so if you're struggling to type fast enough, again, we have link.stthomas.edu/sfpyinfo. And I'm going to have this little orange cloud up in the upper right-hand corner of any slide that has a hands-on. And you can just click in the table of contents to that example and grab the code that, you can grab the code that you're going to need to copy and paste into that example. So, but first, let's all start with link.stthomas.edu/sfpy hello. So let's see, where do I want to drive this from? I think I'll drive from here. All right. So the first thing that this is going to do is ask you for a display name. I don't care what it is. There we go. Anything, whatever's the fastest for you to mash on your keyboard. There's link.stthomas.edu/sf as in Salesforce, py as in Python, hello, all lowercase. And if you make a typo, you'll get a login screen because it'll think that you're trying to create something in this link shortener. So when you get to that page, it's going to prompt you for a username. You just type anything you want. It's not actually runnable yet. This is my code. And what it wants you to do, what I'm going to want you to do is then hover over this right-hand menu and click fork. And it's going to ask you for display name again, and just hit anything. This is actually technically now a new URL that's specific to you. And this will be runnable and editable. So when you get that far, you're going to click the run button. And it's going to say so-and-so is running the code. And it's going to put hello world, which is what we had up there in our print open parentheses, quote, blah, 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 quote, close parentheses up at the top. So our print statement is our very basic. Not on the Wi-Fi?
Oh,
No, just can't see. Okay. Okay. UST-open for the Wi-Fi.
Oh, I just used the open one.
Yep, perfect.
Oh.
Yeah, sorry it's so small. I did not realize, you know what, let me, oh, yes, sorry, I wrote really badly there. stthomas.edu/sfpy ... and the first one is hello. So it's sfpy hello. Yeah. So is anybody online still struggling to do this? Is everybody online? Because it's almost probably easier online because you're working off of print. Has anybody online not gotten hello world in the lower right-hand corner yet? Okay, so raise your hand if you have gotten hello world in the lower right-hand corner. Okay, raise your hand if you haven't yet. Okay. That's cool. This is the thing we're going to base everything off on, so we'll just make sure it works. Yeah. Okay. You know, I have another one we can start you on that has links to all the links.
Okay.
Okay.
Where's that?
It is. All right, so that, if you want to keep it up, we're starting with just this, and that's got the links. Okay, so you're gonna punch something, hit fork, and punch something again, and hit run. All right. You do not have permission. So if you don't have permission to execute the code on this bunk, have you forked it yet? You got to hover over the right. Yeah, right. Fork you too. And then you know, you're going to hover over this right thing, and you're going to click fork. And then you're going to type your name or whatever again, and then you should be able to run it. Hey.
What's the difference between setting up in this box and then
The left is where you edit, and the right is two different output consoles. I have no idea why they give you two.
I know. It's two different types of programming. The right box is what's known as inline programming, where you just type in a command.
Oh, you can type in up there.
And then right below, you'll see the result of it. Whereas the left is kind of more traditional IDE programming, where you put several lines of code, you press run, and then they run in sequence. If you want like instant feedback, testing something in the right will work really well. But if it's something like multiple lines, you have to do one.
Thank you. So yes, to everybody online, you're going to be typing in the left-hand side. Okay, administrator, are you good? All right. Well, I'm not hearing back from administrator, so I'm going to hope so. All right, we're going to go back to our slides. So we.
Actually, sorry, right.
Which way? Restrooms?
Yeah.
Oh, they're to the left.
Oh, there.
Left and across the hall, by the water fountain.
That was right.
All right, so we did that. So now I'd like everybody over in your left-hand side to backspace out hello world and replace that text with the word yay us. What you don't want to do is backspace over the quotes. Those are important. Those say that hello world or yay us is not your code. It's the thing that is text that is meaningful to you. And programmers call that a string, as in a string of letters. I'm going to try to say the word text while I'm here. How we know? We got yay us? Okay. 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 Excellent. How about you? You got yay us? Woohoo! Yay us. Mr. Rowell got yay us? All right. Yay. You got yay us? Woohoo! Oh, yeah, yay me. Okay, fine, but yay everybody else too, dude. You got yay us? Sweet. You got yay us? All right. So you've now run a program and you've now written a program, everybody. Okay, I want to hear the whole class all together. Yay us. Okay. So what we have just looked at is what we did was we altered an expression in our code. And that entire line with the print statement was a statement. Did you do the yay us exercise before you left? Did you get a chance to do the yay us exercise before you left? Okay, have you programmed before? Okay, so we backspaced out hello world on the upper left and changed it to yay us and made sure that when we hit run, instead of saying hello world, it said yay us. Okay. Yeah. All right, so expression is what you're used to in Excel's formula editor. It is, you can type a lot of complicated code there, but in the end, it is a value. it reduces down to the number of 5, or it reduces down to the phrase "hello world," or there is a it's a formula, but like, so type "hello world" will give you this weird code gobbledygook that says str, which is short for string, which means text. But that's still an expression. Like it has an answer. It's like, this is this thing. This is what type of expression the other expression inside these parentheses is. Another expression is 1 + 1 / 5, which in itself is made up of lots of smaller expressions, which again, you're used to from Excel if you've ever done formulas. You can take what's in a cell and you can add it to what's in another cell, and the whole thing turns out a third cell. So you've got like an expression here, an expression there, and then you've got like the whole thing. And it's just like in math, like, how many parentheses can you, like, in your mind draw, whether they're necessary or not, around the different parts of a formula. Does Amanda start with Z or not? That Amanda is an expression. Z is an expression. Starts with is an expression. It's an operation. But you put them all together, like that glue between Amanda and Z, like the answer is false. And that's also an expression. A statement is something that does something. It saves a copy of your expression into a really cool nickname, which programmers call a variable, for later reference, or it puts it on the screen. That's your print command. So that's what a statement is. And a single statement is a program. That's why I said you guys have all written your first program. Just like you could, like, write a single sentence and say, this is my essay. You could, it better be a good sentence if you're going to get an A on it, but you could turn that in and say it counts. A sentence is a paragraph. A paragraph is an essay. And so a statement is the smallest unit of program, and lots of statements put together make up a program the same way that lots of sentences put together make up an essay. And in Python, there are some exceptions, but we're not going to get to them today. But for the most part, it's one statement per line. You hit enter to say that's like your period mark for a sentence. So you hit enter, it's a new statement. Operations, operators, functions, method, you're going to hear them called all sorts of things. But what they are is they're the verbs. They tie everything together. It's the plus. It's the putting the print around something. It's putting type around something. And then you have comments, which is great because you don't really have much of those. I think there's like, you can like right click on cells and put stuff there, but comments, they are code that you don't actually want the computer to interpret as code when you hit run. It's in a year when you look at your program and you're like, was I really ever this smart? If when you were writing it, you could put some comments in saying this next line of code does this. You can be like, I can see why. Okay, yeah, I believe that. And then you can copy it and paste it, because who here hasn't taken a formula they found on Google for Excel and backspaced it, copied, pasted, and backspaced it? It's the same thing with Python. There's also a thing called a multi-line comment, so for the one-line comment, you just put a little hash in front of it, and it'll usually get grayed out in most IDEs, those text editors with the fun colors. And then you just take 3 single quote marks on either side of your multi-line comment if you want to say something and not have it just scroll to the right forever in your code. And then again, an IDE is a text editor with a run button. A data type is something that you may or may not always think of when you're working in Excel, because Excel is so good about yelling at you when you get it wrong. It puts that hashtag n/a right there. You can just see it as soon as you hit enter and you biffed it. You tried to divide a first name by a last name. It'll just be like, what? When you're programming, you kind of got to pay attention to it yourself. And when you're also, because in Excel, kind of the largest piece of data, you work mostly in the range of 0-dimensional and 1-dimensional data. You either work with a single cell at a time as an expression, or you work maybe with a range of cells, and so you say, D2 through D5. And so again, you've probably thought about that somewhat, like, can I actually add a range or divide a range? Does that even make sense? But you really got to think about it when you're coding, and it's not instantly like showing you everything. So being able to think, okay, 0-dimensional, this is like math. 2-dimensional, it's a piece of paper. 1-dimensional, it's a line. So zero dimensional is a point. So single points of data can be a text, they can be number, they can be true or false, which Boolean is the fancy word for. And they can be blank, which is a little different than Excel, because in Excel, it's not always, I mean, there isn't really a distinction between like something being text typed and just happening to have nothing in it versus like being like truly the void. In most programming languages, there is a difference. The commands that we're going to work with do a pretty good job of treating empty text and true emptiness as somewhat interchangeable, but they're not always. So being able to think about, is this like really null is important. Collections are lists of zero-dimensional data points, but when you're talking about tables, they could go across or they can go up and down. And those have different things you can do them, because when they go up and down, you can kind of presume that they're mostly the same data type. That like if the first one is a number and the second one is a number, you can probably sum them all. Whereas if you go like across, they might be first name, birthday, blah, blah, blah. But one thing you can presume about it is it represents the same real world entity. That's a record. And that's special to tables. There are other ways of doing data in 2 dimensions, but that's one of the neat things about the data we work with is that you have this notion of collections of rows and columns that intersect. It sounds so self-explanatory, but it's actually kind of a big deal mathematically. But I'm going to stop geeking out on that. And the main reason to be able to pay attention to that is that how many dimensions any particular piece of data has. So that's the thing, is in Excel, you've probably been thinking of a column as a lot of pieces of data. In Python, you can take the entire column and give it a nickname and now think of it as just one piece of data. Sort of like the way a range is one piece of data in a formula. And so there are things you can add or subtract zero-dimensional numbers. If add means concatenate, you can add pieces of text. You can grab the first letter of text, but there is not a first letter to the number 4 when I represent it this way. And for everybody online, I was holding my 4 fingers up. For text or for numbers, you can check if something is the same as or whether it's less than. In the case of less than, it means alphabetically less than. But then you start getting into things like fetch item number 3 or fetch the odd items or do this one thing but only to every 3rd row, or give me the the sum of all of these. And those are special things that are collection operations. You know what is, yeah, you can't really say give me the 3rd item of the number 5. Like, doesn't even make sense. But you can say give me the 3rd item of a list of numbers. So keeping all that in mind can really help you think about what it is you want to do to your data now that you're not just looking at it and you're having to think about it in the abstract. So the thing that's trickier about programming with Python is it's not necessarily going to, every time you type a formula, just tell you what goes right in it. The documentation that's online will tell you that. It's probably going to speak in a lot of jargon, like calling things string instead of text, but you'll get used to it. If you have a really fancy IDE, it might tell you what could go into it, but for the most part, you're going to open parentheses and it's going to be like, yeah, waiting. So being able to think of that of it yourself and read the documentation is helpful, although you can always just guess, and it will still give you an error. It's just that it'll give you an error in plain text in the bottom of the corner instead of like as soon as you start typing. And the other thing that's more complicated about Python is that the operations get a little weirder looking. So you've got normal things like the plus sign that goes between 2 numbers, or you've got, in Excel you've got is number, and you can put apple inside of it, and it'll tell you nope. But in Python and Pandas, you've also got things where you put your expression, and then you put a dot, and then you keep typing some keyword, and then you put parentheses, and maybe there's even more. They're called parameters. They're settings, basically, inside the parentheses, or maybe it's another expression, like apple starts with Z. You've got even weirder ones that have 2 dots inside of them, and then you've got other things where you can like hook them. You can like hook multiple of these together, and each one of those is a separate operation. But this is actually all just sort of one operation. And you've got other ones where like you type something, and if what's inside of it is a table, then you can just put little brackets after it and do more stuff, and it's all way weirder than Excel looks. And that's where we're going to have fun today and get used to this and see it all. And if in a week all that's really hard to remember, that's okay. Keep calm and think about your data types, because you'll get there. Just like when you see a really complicated Excel formula and you need to break it down, you copy and paste it into a text editor, and you take like maybe the innermost parentheses and you just put them in a cell and see what it does. And then you take like the next widest set of parentheses and you put it in a cell and see what it does. You can do the same thing because you've got your print statement. You can put print parentheses, type parentheses something, and actually have Python tell you what it is, and then you can Google that. You can, once you figure out something, like you've got like your middle parentheses of your expression that you want to build, you're like, okay, I understand this. You can set it aside into a variable name, and then from then on you can refer to it by that variable name instead of having to retype it and keep track of all those parentheses. And so if you're confused, you know, like is 9 minus 4 is less than 2, you're like, wait, is that going to be a number or something else? You know, you can just take it apart, put it inside print and print type, look at it, and, you know, think, okay, 9 minus 4, that's just 5. You know, 2 is also a number. 5 is less than 2. No, that's going to be a true false. So do that, you'll get there. It's not, it looks scary at first, but this game is all it really comes down to, and it's just new. So again, yeah. Recommended IDEs. Okay. Well, I would say number one thing is do not use an IDE like CodeBunk for corporate data, because I have no idea where anything you're typing is going. We're all going to be using data that I made up today. I would say with an IDE that you want to download because you actually do want to do this with corporate data, I'm going to have, at the final slide, I'm going to have some information about, I made a blog post about installing something called WinPython if you're on a Windows machine. If you're on a Mac, I believe an older version of Python called Python 2, which has a slightly different set of commands than this newer version that they're trying to get everybody to use called Python 3, but not everybody likes it. If you're on a Mac, it's sort of already, I believe it probably already comes installed on your computer. As far as making sure the code can run, but then, yeah, you probably still want an IDE to make it run, and I don't know much about that, but you would Google IDE Python. And there's something called Anaconda, which is very popular, and you can just download it as like an installable thing, and it'll sort of take it, make it all nice for you. And then there's something included in that called Spider with a Y. It is a really popular one, and I don't know if it's, I know it's popular on Windows. Is it? Pooh, what would you like? You're more into this than I am. PyCharm. Okay, so one of our lab assistants has said the Jupyter Notebook is nice because you type, you hit run, and it can make your output look a lot more friendly than what we're doing today. And it's going to be a lot more visualized, and you can get a lot more of that kind of preview that you wouldn't get in Excel, and that with a million row table probably you wouldn't want to do. PyCharms is JetBrains.
Yeah.
Okay.
Yeah, Jupyter is kind of like a fusion of CodeBunk and the traditional desktop IDE. It's usually run either through a server or locally through your local host.
And Jupyter spelled with a Y. And basically, anytime any word in the English language is spelled with a PI, they're going to replace it with a PY in the system name so that then they can make it more like Python. All right, so print statements using variables, taking things when you're like, okay, I've got this, but my brain is barely holding this, giving it a nickname so that you know that represents what it is to you, and using comments. Those will help you. And don't ever be ashamed to Google something this simple. I Googled everything. I put in this not just to make sure it was going to work and was correct, but because I literally don't bother to remember because we have Google. So that's fine. All right, so we're going to stay on SFPY hello. Has anybody closed it? Yay. Okay, so you're going to either backspace or comment out your old code. Can anybody remember how we would comment out that line that we typed? Yep, hashtag at the beginning. All right, so I recommend typing and running these one at a time. So just, type one line, hit run, add another line, hit run, watch them both pop out. And before you finish typing each line, try to guess what you might see. And keep in mind anything where you're surprised about what you see, because I want to hear about it. And raise your hand if you have any troubles. No, you can leave them all up, or I mean,
it'll just keep printing out in the floor.
You'll just get longer and longer output every time. Yeah. Yeah. That is, so that little thing between the open and close, the less than greater than signs, and then class, and then something in quotes. That thing in quotes is what you can Google when you're like, what is that? You can just Google Python and then str, and it'll tell you more than you ever wanted to know about it. But also somewhere in there, everything you actually wanted to know about it, including what kinds of operations it has. All those weird dot blah, 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 blah. It'll tell you about all the ones that are included, so that then anything that when you put it inside print type and it tells you that it's str, it's like, well, I can do that to any data that's like that.
Kind of again with the jargon thing, class is the Python output version of type. Class and type version.
Caps matter sometimes. That's a great question. Thank you, Monique.
For typing commands.
Yeah. Yeah, so like hello world, if you type hello with a lowercase h, well, you'll get a lowercase h as output. But with none, the word none without quotes around it is actually a special command that represents that idea of nothingness. And it has its own type, you'll see that. And if you try to put quotes around it, instead you'll get the word none, as opposed to like the nothingness. And it needs to be capitalized to actually, and the same is true with false. It needs to be capitalized to be the special word. And it should show up with a special color as you type it, if you get the capitalization right.
Yeah, there's the one slightly annoying thing about Python, but it's also kind of a good thing, is Python is known as case sensitive, where you have to have everything exactly right for everything to run correctly. So if it has to be a capital F, it has to be a capital F, and put a lowercase f, it won't know what you're talking about. So just an important thing to remember, that everything has to be exactly like it's on the screen.
You can always try it with a lowercase and see what happens.
That's true. We're not going to break anything here.
Yeah, you'll get a random output.
Yeah. Really? Whoa. Okay. What happens if you hit your URL bar and hit enter to refresh the page? It should, and hit. All right, try hitting run again.
This might be a connection problem.
This might be because we're all doing it at once.
It sounds like what's happening is that the terminal is continually trying to reconnect to the internet. So that might be what's happening.
I just got to know.
So we killed CodeBunk.
I think the connection got killed.
What connection?
The internet connection.
UST Wi-Fi?
And you're still
No, because we're still refreshing the page.
okay.
No, I think CodeBunk is kicking us out.
Yeah,
That
because
could
some
be,
people
yeah.
are on.
Okay, so
CodeBunk is getting.
I think that might be the case. All right. So I have a plan B for everything. Every time you see a link now, so for example, we had link.stthomas.edu/sfpy hello. We're going to do sfpy hello hyphen lowercase b, as in plan B. And we're going to hope this one doesn't kick us out. And I'm trying to think. So the problem with this one is not only will it take a while the first time you hit run, when you first pull it up, if you want to run it as it is, but then so as soon as you change it, like I just hit enter, you might have noticed it said it was forked, and that impressionable rising levels that's up at the top, you'll have something else if you start trying to edit this. So that's how you fork something in this backup IDE, is just to start typing. But so when I do that and I say print yay, and I hit run, oh, it ran fast. It never runs fast. Okay, well, when we're going to get later into our stuff involving pandas, it might not run fast the first time, but then like the second, third, and fourth times it should run fast, but it can take up to a minute to run, which is why I had chosen CodeBunk. -B. Yeah, so I'll put that in the chat room. All right, and for everybody, if you want, I hope it doesn't take you guys too long, but let me put that code back on the screen. Is everybody enjoying this thing of playing with it one line at a time? Do we want to start that over? Or do you want me to put the answers up on the screen yet? Okay.
Yeah, no, everything's
okay, great. Okay.
Yeah. Yeah, that one should error. I'm not sure what you're talking about.
Oh yeah, SFPY hello -B. Yep, and then you can just hit. You can just start to type. Just start typing. Like hit enter, and then yeah. Now you can see you've got this weird jargon, and you're ready to go. You can start doing your thing. So it sounds like CodeBunk came up, and so we'll just toggle back and forth as needed and hope that both systems don't kick us out all the way at the same time. People wearing lav mics probably shouldn't play with crinkly stuff.
Question about quotations.
Thanks.
Is there a difference between using single or double quotations?
You haven't noticed anything yet, and there is not a lot of difference, except that people often switch, but because you're possibly in many contexts more likely to almost, it's hard to say whether in English you're more likely to want a single or double quote to be inside your quote, but whichever one you use on the outside, you can use the other one on the inside as plain text.
For what we're doing right now, it shouldn't matter, but if it indicates, especially where the quotes are being an expression instead of just a string, then it does matter, because what you'll sometimes happen is you'll unintentionally be breaking up your expression. If you say, let's say, an expression is supposed to be like S plus a string, like string plus string equals something else, where if you try to do double quote string, double quote on the outside, double quote on the inside, A, plus double quote on the, and then A, B, then try to close it out with double quote, what the Python script will read that as expression A, expression B, and then an empty on the outside.
Yeah, so like if your expression is just a sentence, she told me hello, and you want to put hello in quotes. If you put that whole thing in double quotes and then hello is also in double quotes, but you've just meant the whole thing to be in double quotes, you're actually going to stop it right after the space, after the word me. And then it's going to be like, wait, why are you trying to give me a command called hello? There's no command called hello because it's going to think that you're done with your quote. So then you would want to put the whole thing in quotes. But on the other hand, if you have apostrophes in your data, maybe you want to use double quotes on the outside. And if you have both in your data, like she hasn't told me hello yet, one of those two, you're going to have to do what's called, God, why can't I remember the name? Got it, backspace. Backslash. You gotta escape. Thank you. With things that have meaning in the code, if you run into a situation where you need to put it inside of text, and it's like, wait, is that code or text? You can usually put a backslash right before it. So like backslash apostrophe is like, I just mean apostrophe.
Yeah, apostrophe is a great example where we just want a string that has, let's say like Mitch's or Katie's. You'd have to put that inside double quotes because otherwise you'll see that single quote and be like, you haven't finished this.
Yeah.
This doesn't run.
Yeah. So the main difference between single or double quotations is lazy programming. Whichever one you think you're going to have to backspace, escape less. Also, I like the single quote when I don't think I'm going to have to escape anything because then I don't have to hit the shift key with my pinky. There's a lot of programming conventions that come from being lazy. Hi. Yeah.
Anyone ever just use like the STR and then parentheses for what you're trying to take single and double quotes? That's something kind of helpful.
It's probably not a bad idea.
Because then you'll have data types where it's like if you have a double and a single, you'll have that issue. Put whatever you want to put as a string.
Can you do that? Because I know that STR you can put like a number in it and it will turn it into like basically that you know, you can put a 5 in it, it'll turn it into 5 implicitly surrounded by quotes. Can you put hello without quotes inside of STR?
I think that basically specifies the data type.
Technically, no.
Okay. It's still expecting something to be in there that it understands.
Unless you have a space in what you're trying to turn into a string, it'll be complete.
Because the thing is, you could put str around the word hello, but what you did earlier was you assigned a variable holding the number. You assigned the number 5 to a variable that you called hello. Yeah. All right, I'm gonna show some answers. Was anybody surprised by anything they saw? Yay, let's talk about them.
A Boolean is essentially a yes versus no, a true versus false. It's a logical.
There was a guy named Boole who came up with how to add and subtract true and false. And so now everything having to do with true and false, we call Boolean to honor him. Yeah, B-O-O-L-E. Yeah.
Well, I guess I still understand the whole class thing.
Oh.
Why it's coming with class and what does it tell me to go Google it.
Sure. Class equals type. Essentially, it just means that class is the Python program's way of telling you what type what you put in it. So let's say if you had a string that's
it's the cookie cutter, not the cookie.
Sure.
In programming. It's the cookie cutter, not a class or a type is the notion of the cookie cutter outline as opposed to the cookie you made from it. So the cookie you made from the notion of string is hello or yayas. Yeah, and the idea of just text, that's called a class. Like the idea, the data type, the idea that this is a thing that I can alphabetize. This is human language. Like, that's a class. The idea of this is an integer. I can add or subtract these or tell which one's bigger or smaller. That's the class. That's the cookie cutter.
So, when it's saying it's class Boolean, it's saying what I'm asking for, what I put type is a Boolean.
Yep.
It's saying it's in this cookie cutter Boolean.
And it's saying, because if you would put false in quotes, even with a capital F, it would say, oh, that's a class str. That's the word false in English. Whereas if you put it without the quotes, it's being like, yeah, I get it. You mean like false, false. Yeah.
is not necessarily how a program would describe something. Like, for example, we would say that hello world is text, it's words, whereas Python would say, oh, that's a string. Whereas we would say, like, oh, text is, it's a type of text. Like, hello world is type text. The Python script will instead say it's class text.
Or class string.
So do we just use this type function to find out what it is?
Yeah.
Mm-hmm.
I'm making mistakes. I'm trying to figure out.
Yes, you're making mistakes. You're trying to figure out what it is. You're like, why can I not add false and somebody's last name? Oh, right, because one is a Boolean and one is a string. And if I Google what happens when you add a Boolean and a string, it gives me an error. I don't actually know if that happens, but that's the kind of keep calm and inspect your data types and break it down into smaller problems that we're practicing right now.
That's actually a great way to put it. Type is the Python and robot.
Yeah. I like that. I got to put that in my next slides. All right. Okay. Yeah. And is anybody surprised that we had a round number, but it didn't come out an integer? Yeah, so float is another, it's like Boolean. It's another thing that is really computer geeky. It basically means decimal. It means number that has a point in it. They call it floating point for reasons that are more abstract. I don't even know right now, but you can basically translate that in all programming languages to decimal. And the reason that it came out that way instead of as an integer is because we multiplied 3 and 4, which are integers, by a decimal. And so it's like, well, I'm going to make the answer decimal too. There are commands to change that back into the integer 30 if that's really important to you. But a lot of what we're dealing with, if it's coming out in your results CSV file with the 0.0 and you're like, God, that's ugly. There are commands to deal with that. And again, just being able to check on it and say, why does it keep coming out with a 0? I'm sick of this showing up in my data. Knowing that you can put type around it and figure out what's going on will help you Google a solution. All right, any other questions? Fabulous. Okay, so I have a pop quiz for swag.
So you can I ask a question?
Yeah.
So you can tell your code to, if the type is something, then do this routinely.
Yes.
Or if it's something else.
Yes, you can.
Then go this other way.
Uh-huh.
Ah.
Yeah, so that's true. You can not only use it for your own dummy checking, you can use it for control logic. Yeah. Yeah, you want to make sure it's a Boolean before you do that, for example.
Because if I have like a day's worth of data, I'm looking for something that has this checkbox.
Yeah.
And that day there was no checkbox.
Yeah.
I don't even want to do that.
Yeah. That's true. Yes, you can also use it as part of the program, not just for your own dummy checking. Okay, so question number 1 is, let's see. How many expressions do you see in Angela starts with P, total? Just raise your hand if you want the swag. Calling it. Okay, 3. Which ones? Okay. Does anybody have any alternative answers? Okay. Do we get any other guesses? Okay. Okay. Sorry? All right, I'll give you a hint. Starts with is not an expression. Sorry? Okay. Oh, sorry, just the first line. We're just working on the first line. Okay. You want to take another guess? That's it. 3. You got Angela, P, and the whole thing. So when the computer is like crunching these, it's going to compute Angela and be like, got it, that's text. It's going to compute P and be like, got it, that's also text. And it's going to compute the whole thing and be like, got it, that's false. So the computer is crunching 3 expressions. And all right, so do you like food, office supplies, or clothes? Okay, we have Tommy t-shirts and a sweatshirt, and we have chocolate, and we have chocolate. All right, I got more chocolate in this. Sorry if that's really loud, everyone who's near my listening through my mic. Thank you. All right, we got it. We got another problem now. This one's a little harder. In the second line, how many total expressions are we dealing with? Good. Anybody have any alternative guesses? Do you have your hand up? Yeah, okay. Okay. You guys are, like, think of it like, how many places could you draw parentheses around it if you just wanted to get really parentheses crazy in math, even though you don't need them because of order of operations? Does anybody? Okay, so let's see. We've already, okay, so we're gonna start listing them. We're gonna do this one. All right, so we've got, does everybody think that 3 is an expression? All right. What else is an expression? All right. What's another one? Okay, what's another one? Okay, 3 times 2 point. All right, any others? Okay. 3 times 2.5 times 4. What else? And then all. All right, so 1, 2, 3, 4, 5, 6, 7. More chocolate, office supplies. T-shirt? Okay. All right, so the reason I did this game is because, like, again, that whole thing of what is this? That game of why is my code not running? This is going to help you. That whole game of I found really cool code on the internet. Google says this works, but obviously it was somebody else's business problem. Now I have to make it work for my business problem. And I have to backspace out just the right parts, but not the wrong parts. If you can figure out how many parts there are, this, like, getting good at this will help you surgically edit code from the internet really well. All right, so any questions? Where are we going to next? Any questions right now? Oh, how is it 7? Okay. Yeah, okay, so let me just add to the chat. I'm just going to type number 1. Do you mind typing them into the chat? Okay, we're gonna have Monique add them into the chat, and just list out the ones that we listed on the board. Great question, thank you. All right, so we are now going to go to a new website, link.stthomas.edu/sfpy read CSV, all lowercase. Again, if we have problems, we're going to switch over to /read CSV-B, but we'll start with just this one. And let's see, do I still have this? No. I'll leave this up on the page for just a moment. Yep. Every time we pull up a brand new link. All right, so we have 3 files that we'll deal with. The first one is just a small context table type file. Or maybe it's like from an external data source. And so we've got like this data sources like row ID, and we've got Jimmy Buffett and Shirley Chisholm and Marilyn Monroe and Cesar Chavez and where they work and their email address. And that's all we know about them from this data set. So first thing is just run it. Make sure, like, let's just see what displays after you fork it when you run it. Yeah, actually, I don't even run. I should go there and pull it up and see what we get. All right, so I'm going to run it. And we've got a whole bunch of stuff printing out. Yeah. And so if I scroll up a little, I'm going to move this out of the way. I'm going to scroll up a little bit. Oh, yeah, sorry, there's a lot of stuff that showed. So I scroll up to, so first thing that we did was we printed just some plain text. \r/n just means give me a couple of line breaks. And then I put some dashes. Those don't mean anything special. I literally wanted dashes to print out just to make things easier to read. And here are all the rows of df1. df1 is a variable name. So first thing we did in our code was say import pandas. Pandas is the name of our extension for Python. It's got more commands than native Python comes with that is really good at handling spreadsheets. And then the second line, set option, blah, blah, blah. This particular one would have tried to wrap onto 2 lines if I hadn't done that. So that's what that was for, was to get it to show up all on just 1 line per row as long as there's enough room on the screen. And then we took 3 different CSV files that are out on the internet and saved them into 3 different variables called df1, df2, and df3. Again, speaking of computer code giving things weird names, Pandas likes to call tables data frames. I think it has something to do with statistics. It was kind of invented as an R competitor. R is a piece of software that statisticians love for crunching data. And so the table goes into a class called a data frame, called a Pandas data frame. And so I like to, when you find code examples on the internet, people will always say df equals and then like put the data into it. And so that's just the convention. People also, you'll also sometimes see people say import pandas as PD. And then instead of saying pandas.readcsv, they can type pd.readcsv. And I guess it's that people are lazy about typing the word pandas. So that's what that does. You'll see that. So a couple of conventions when you find stuff on the internet. But all we're doing is taking that data that's in our CSV file on the internet, and we're sucking a copy of it into our environment, not the original. Anything we do to it, we're not actually saving back onto the internet. Yeah. Yeah, expand frame, I don't even know what the repr stands for, but it's, for some reason, after about 4 or 5 columns, it decides to like break things onto new lines by default. And so I had to turn a setting that's very annoying that comes in Pandas off to make sure that these things were actually readable for the class. It's just a display setting. Yeah. And so yeah, we're just importing copies of our CSV file into what's known as memory inside of our program, and giving them nicknames. So the data type, if we were to, do we have type? Yes, we do. So when we just say print df1, like that whole thing is a data frame, and its behavior when inside of a print is to just show you line numbers and column names and all of your data. It looks kind of spreadsheet-like. You may notice that it starts with 0. Programmers love to start counting with 0. Very confusing, but you guys are all Excel whizzes, and you have to start counting from 2. So maybe a little less confusing, or just the other way around. Because every time you have column names in Excel, they take up line 1. So yeah, everything's going to be 2 less than it is in Excel. And then we have another command. We have an operation that we can put after df1 in our code called .head. And if you don't put any options inside the parentheses, it presumes you mean the first 5 rows. So this will do pretty much the same thing, but it'll stop displaying data after the first 5 rows. You can also use it as a control function. It's not just inside of print. Like if you literally want to like extract the first 5 rows of something, you can actually like put it into code that saves that extraction to a brand new CSV file. It's a totally legitimate thing that when you say df.head, what comes out is a new copy of df that only has the first 5 lines. There's a similar one called tail, and it's the last lines. And both head and tail, you can actually put a number in there. By default, it's 5, and the documentation will say default is 5. But yeah, you can specify a different number if you'd like. So that's what's coming out next. And then we're back to that whole class thing. And now you can see we got a lot longer thing in between the quotes. So this is where I really say, like, by the time you start getting that long, you probably don't even have to put the word Python in your Google search. You can just put that whole thing in quotes, and the documentation will immediately come up. So that is the, sorry, this one. That is the full technical name of what Pandas likes to call a data frame, and what you and I would probably just think of as a table. If we put df1 inside the len for length command, we get how many rows are in it. And if we, let's see, if we say that we want to see dot columns, we get a list of its columns. And if we put df1.columns inside type, again, bunch of gobbledygook you can Google. And but we're like, wow, that's really ugly. It says the word index and it says dtype object, and that's all very much more than I needed to know. Maybe you've got like a really wide data set and you literally just wanted like a list of the columns because it's so wide you just didn't want to have, you were like, I don't even know what's in this spreadsheet. So that can be a nice command. You can put list parentheses df1.columns, and that will strip out all that gobbledygook and just make it a nice little native Python lists, plain old lists. They come in brackets and they're separated by commas, and you can like copy and paste that into, I don't know, something. I actually do a fair amount of putting list around things in Python and copying them to my clipboard, especially if I'm going for like, show me all the unique names, or show me all the columns that start with this word. I want to know what actually came out in my spreadsheet. I often take the output and put it in list, especially if I've maybe alphabetized it or something like that. I'm just like, copy it to the clipboard, go do my work elsewhere. And you can see in class that that's much simpler. It just says list. It doesn't talk about pandas and all sorts of stuff. It just list comes with Python. And then, what did I say? I think the last thing I did, oh yeah, this is trying to hide the code on me, but we can do it as, we can also put sorted around df1.columns, and there's an implicit list in sorted when it comes to columns. It doesn't always work that way, but when it comes to take a data frame, put dot columns, if you then put sorted around it, it's like you did sorted with list first around it. And so it's just going to come out very simple. I didn't have any lowercase and all uppercase, but that is case sensitive. So if you want to make it case insensitive, that last command, the key, that's lovely that that's covering the page. Nope, that's not helping. I don't know why that's hidden. Anyway, that last command that you guys have all got up, that's the thing that's going to make it case insensitive. So going back to our slides. Oh yeah, question. How do we import our data if it's just local? You would, instead of type in those little quotes, instead of typing http:// something, you would type maybe c:// something.
It would just be the file path.
Yeah. All right, so we all got it to run. There's also a read Excel command. So it can be touchy if you have weird things like grouped cells and whatnot. But if you just have a simple spreadsheet that's very tabular, like a plain old CSV file, or you have one with just a couple of sheets in it, but at least one of those sheets is nice and just plain old data, then it's got various commands for saying which of the worksheets you want if it's got multiple worksheets inside of it, but you can also read an Excel file that's laid out like a simple table. And when we finish manipulating our data frame, like taking just the first 5 lines or just the last 2 lines, we're like, okay, I'm done, that's good, that's the way I want to see my output. You just you save that into a variable, or not, and then you just keep typing .to_CSV, and again, you put some quotes, and you put a file path like c:// something else, and you run your program, and in that case, in this case, you might be doing it instead of putting it inside of print commands, or maybe on the next line afterwards. And so this line, it won't actually show you anything when it does it. So you'll be like, did anything happen? So you'll just have to go check your hard drive and see if it did. It won't work if you've got the file open in Excel already. So make sure if it's like, I don't know what to do, file's open. Check if you've got Excel open. And I also cannot emphasize enough, don't save it to the same file path that you imported your original CSV over. You guys have probably all, I mean, you work with Excel a lot. You probably all make a backup of your original spreadsheet before you start messing with it, and like put it in a place where you can't accidentally get confused. You like call it backup and you put it in a totally different folder on your computer. It's the same idea. Just don't accidentally overwrite your data, because you can do anything you want inside of Pandas, and you haven't actually messed up your CSV file until you save it to your hard drive over the original CSV file. So this can actually be great. You actually literally can use Python just to turn a CSV file into an Excel file or vice versa. 2 lines of code. All right, we got another data set. We got a bunch of people, some of whom we're seeing for the second time. Other people are new to this data set. They may or may not have the same email addresses on file in this other database that they had in the first database. And they've got totally different IDs because it's a different database. And in this case, we know their favorite food, not where they work. So take your code, and I want you to edit it. The first thing where we import it into df1 and df2 and df3, don't change those, leave those alone. But below the thing where I wrote don't edit above this line, take every single time it says df1, including in the little things that are the labels, and just backspace out the 1 and turn it into a 2. So we're gonna look at the same stuff about df1 that we looked at, or we're going to look at the same stuff for df2 that we looked at for df1. I mean, you could copy it into your favorite text editor and do a replace, but probably not in CodeBunk. Yep. Including in the labels, otherwise it's going to say here's the number of rows in df1 and actually give you the number of rows in df2, and then you'll be confused. Yeah, not the very top ones above the don't edit above here line. And then you can click run after you get done with that. So are we seeing, has anybody not gotten it to run yet? Lollipops, kale, and amaranth. It's a leafy vegetable related to spinach. Amaranth. Amaranth. Actually, I'm not sure it's related to spinach, but it kind of tastes like it. I think I have that by Vandana Shiva. She is a really big proponent of eating leafy greens that people normally consider weeds because they're much more environmental to grow. Yeah.
My wife said that.
Yeah.
I don't buy it.
And amaranth is a weed that interferes with corn, so I thought that would be fitting to put by her name. All right. So did anybody not get like it showing that it had 6 rows, for example? Okay. We're going to do it again, just to really reinforce it. And now we have our third data file that we'll be working with today. And this is 9 people, again, from a totally different database. And we have their first and last names. We have their date of birth in a month, simple day, year format. And we have their street address. And if we look at this, we'll see a lot of people live together. We got maybe some families going on here. We've even got, I don't know, I've decided that they're twins because I have these neighbors. They're so cute. They're sisters and they're like in their 80s and like, I think they're both widows and they moved in together and they have a house together across the street from me. And so I decided that we have twinsies who've moved in together. And so we're going to do the same thing. We're going to change all the DF2s to DF3s. And so we should see our total row count when we run it go up to 9. What's interesting?
Well, we're not really telling you anything about it.
What do you mean?
I'm just saying, here's some data. We're not really telling you anything about it.
Oh, like whether yeah. No, it figures out how many columns and rows there are. And it takes its best guess about what data type each row is. And sometimes it might guess wrong. We might even cover that today. Did I? Thanks. Sorry?
So it's basically looking at columns that it's going across and going until it gets.
Yeah, when it hits a new line. Yeah, it's a CSV file. So sort of the same way Excel knows how to take a CSV file and just arrange it into columns when you double click on it.
So one thing you'll end up learning about Python packages, especially, is that while we might be typing print.df.tail, if you look at the actual code that goes into .tail, like we broke out the package and looked at the different lines of code that go into the one little line, it's lines upon lines upon lines of code. What packages essentially do is it's a lot of work that other programmers have done in the past that have gotten you to the point where you can just type in a one-word expression and then you get the results you want. Especially so the functions are basically just a bunch of code that's been packaged together into really easy to use functions.
I know, right? Yeah. Okay. Yeah, let me think. Let me just check. When am I going to? Oh, let me get. Hey, look at that! Yay! All right, 10-minute break. All right, we'll do a quick Q. Yeah. You wanted to see these people?
Yeah.
All right, so let's all. Anybody who needs to go on break, let's be back by 1:10. Okay.
It's just interesting that you do have comments in your address.
had dealt with those.
Oh,
I'm
my
just saying-
CSV file has quotes between all of the normal comments.
Okay, 'cause I'm like, data is not always clean. And so when
My data
when you
is
start to
clean.
have comments in the data, I'm like, ooh, that could get messy.
There are some things you can do with read CSV that will help account for that. There are settings. There are a lot of settings
All right.
that you can deal with. There are also things that don't have to do with pandas that maybe you can do with traditional Python programming, like just loop over every line of the file, interpreting it as plain text, but doing the same sort of hunt for this and clean it and write this file back out, and now I'll pull it in with pandas.
Okay.
So, yeah.
I think in Pandas, I think it might be programmed explicitly into the package already that it's inside of the cell. It's supposed to be string and not taken as actual comment.
But yeah, if I had dirty data, if I had not put the quotes around it between my actual commas, yeah, we probably would have ended up with like a lot more.
Yeah, especially if you're putting it in direct.
Okay, assuming the rows. Okay, it's cool if you run some backup IDE that's more visual. Oh, okay. Assuming some of the rows have email addresses in common, is it easy to augment the DF1 and DF2 data using email as a common key? Yes, it is easy. It is basically a VLOOKUP, and I don't know if we're going to have time to get all of it. It's at the end of the slides. So we may not get to practice it today. In my example, we're actually going to match it on first and last name because I really wanted to show you one of the best things is how easy it is to take multiple columns together as like both first and last name all have to match. All right, I'm gonna run to the bathroom too. I should turn off the mic before I do that. recording. All right. Are we ready? Yay. Okay. So one thing I put up on the screen because someone in the chat asked, and let me just make sure my microphone has any levels. Okay, chat, you hearing me well? I'm gonna wait for one person to type. Yay, thank you. Okay. All right. So we will take, yeah, I'm gonna leave this up on the big screen. But one thing I pulled up because somebody in the chat asked, they noticed that our first sample file and our second sample file had a lot of overlap. And they said, can I like VLOOKUP those on email address using Python? And I said, not only that, but we're actually, at the end of the slides, I have one where instead of doing it on a simple email address, which is not that bad in VLOOKUP, but if you want to do first and last name, like it has to be the you know, it can't just be John or Smith. It has to be John Smith, even though those are in different cells. That gets really annoying. You have to concatenate them, and then you have to do your VLOOKUP on that. And so I wanted to just give you guys a taster of where we're heading with all this. And this is one of the simpler things we can do is to put those two files together. I've got them at the bottom. I'm saying, check if their first and last names match. Include everybody from both spreadsheets. But if they match, put them in the same row and just combine all their data from the two spreadsheets. And we actually, yeah, okay. So we're going to match on first and last name. And one interesting thing is this guy, Albert Howard, in spreadsheet 1, he was ah@example.com. And then in spreadsheet 2, he was ahotherem@example.com. So just like when I don't know how much you guys have done this kind of multi-column thing, but what you define as whether someone is the same person or not is going to determine whether somebody shows up on the same row or not. Whether you actually want to just connect somebody on name and email, or whether that's not specific enough, and maybe that's actually two different Albert Howards, that's a business decision. Just wanted to make sure you know that. And so this is what happens when you're like, first and last name will be good enough. It's like, okay, well, we'll show you both email addresses and presume it's the same person. But in just 3 lines of code, we can say that we're going to take df2, we're going to rename its columns so that their spellings match the way we spelled everything in df1. That's all we're doing there. And we're going to save that renamed copy of df2 into a new variable called betterdf2. And then we're going to say that we want to take df1 and dot merge command it with betterdf2. This how equals outer means that we want every row from both spreadsheets, whether it's got a corresponding match in the other or not. The other 2 major kinds are called left and inner. Inner means only people who are in both spreadsheets. Left means only people who are in this spreadsheet, not people who are only in that spreadsheet, but give me some details from the second spreadsheet if they do appear there. And then we're going to say on is last and first. That's what we want as the definition of who's the same person. And then the suffixes thing, the default is _x_y. I thought it was clearer to say CSV file 1, CSV file 2, so that like in the case of email where they both say email. Now, if I hadn't renamed EM to email, it would have just been EM and email. But what this says is like, if there are anything besides the things that you're actually connecting people on that happen to share the same column name in both, both files, what do you want me to do to make it obvious to you which comes from which? So I said, well, name it CSV1 and CSV2 so you can see that this one got the CSV1 and that one got the CSV2. There it is. We've got holes for people who weren't in the second data file or weren't in the first data file, but we've got like full details about people who were in both data files. And the last line of code is actually just the one that puts it out to our CSV file. We said we want to put it to C:\\. Oh, remember that whole thing about escaping characters? A backslash is the piece of text that makes other piece of text count as themselves, which means that it also has to be escaped because otherwise you wouldn't know it. So this is like actually part of our string. It's actually part of our text. It's like, this is my spot on my computer where this goes. So we have to put double backslashes. So that's what's going on there. And we're going to say, call it outer merge.csv. Index equals false means all those 0, 1, 2, those row numbers. We don't want those as a separate column in our spreadsheet. Just throw those away. And then quoting equals 1. If you want clean data, when you write stuff out of Pandas, set quoting equals 1 because that'll have quotes around everything, whether it needs it or not. And then you'll feel lovely about your output. And yeah, so that's what I got. Obviously, it will not come with the pretty colors. I did that. So that's a taster of where we're going with all this. I don't know, because I feel like, Again, this took a while to write. Less time the more you get used to it. But once you've saved it on your hard drive, like that's it. All you got to do is like backspace out like the CSV file you're pulling in. And you've saved this pattern forever. And it's going to be so much faster than doing all that concatenate VLOOKUP stuff. So that's the promise that I have you all here for. But we have to get through all this before we get there.
So in the real world, would we do this on that Win Python thing? That's what they're called.
Mm-hmm.
So we download that and we can get similar to what we're seeing in our browser right now. It looks similar to that.
Very similar. Yep. Good question. Yeah. So for the chat room, they asked if in the real world you would download something like WinPython or PyCharm or Anaconda, and whether it would look like what we're doing in our browser, because that's what how we would use our actual corporate data to do that kind of thing. And the answer is yes. All right. So hopefully everybody still has their old code just still sitting around. If you don't, you're going to want to go back and get it back on the screen. And we're going to comment out everything we did before, not the part like above the don't touch me line, but all the stuff that we were editing. Just go to the line before it starts and hit single quote, single quote, single quote, and go to the line and after it ends and hit single quote, single quote, single quote. And that way we're not going to get all that garbage printing out as we write our new code and run it instead. 3 single quotes in a row at the beginning of that section that we were editing before we went on break. Yep. And then 3 single quotes in a row at the end. All right, so then once you've done that, you're going to just hit enter, and you're going to add a new line of code. And so we're going to work with that one with the addresses, df3. So you're going to put a big block of code inside of print parentheses. You're going to type df3, and then you're just going to keep going. And with no space, you're going to add an open square bracket. Then you're going to type single quote, address with a capital A. And the capitalization does matter because it wants to exactly match the way the column heading is capitalized in your data. And then single quote again, and then a closed square bracket, and there's no space, goes straight into a dot. And then the word unique, open parentheses, close parentheses, and then the last closed parentheses is to close out your print. And there's no spaces in any of this. And then you can run it. So what you should be seeing is a list in square brackets with each, and then like each value is in quotes, although there aren't commas between the items. So that's a little weird, but it is what it is. So are people seeing that? Our 4 unique addresses where people live. Awesome. If nothing other than unique, this is great. Nice. Yeah, if you have a 1,000,000-row spreadsheet and you're pretty sure that most of your data is what you expect and there's only one of 5 values, and all you want to know is if somebody messed up, just running unique on that column where you want to know somebody messed up, it can be, it's unique is kind of like filtering in Excel and then clicking the filter and like scrolling through what the values are. Yeah. Annie is saying accept better. It kind of is, because you can take that and use it in code and do even more stuff to it. Sort of like with type, you can use it for dummy checking, but you can also make it part of your logic.
Then the script's not going to miss anything. Where if you're going through a list of unique values, it's going to miss something.
Yeah.
This one seems.
You have, okay, so you have this one, and then it stops, and there's no comma. And then there's that one, and then there's a line break. It's just like, it's actually 4 addresses.
Oh.
Yeah, it's just, it's a little awkward with the way it displays. I think our next one. Yeah. So one of the things is if you don't like the way this list looks, because it's hard to follow, you can put a list thing around it, like inside the print, but outside the DF3 unique, and then it will actually have commas between the things. So our next one that we're going to do is we're actually going to count how many are in that, because you thought you had 2 because they just happen to be line breaking in an awkward way. And if we had like a lot of unique values, like 4,000 unique values, we'd be like, ugh. But maybe we actually know that it's supposed to be 3,897. And we're like, no, 4,000 would be wrong. Like, we actually know what we want the answer to be. And sometimes we just need to know how many there are to know whether it's right or wrong. Our next exercise is going to be to modify the thing that we just typed and change it. Yes, I might change. I'm going to send around both the slides and the video. And I think what I'm actually going to send around is a link to a page explaining that the links inside the video are no longer applicable, because I'm going to change all the links to have today's date in them. But the slides, before I publish them, I will make sure that the links are accurate. And the info page, I will archive with accurate links. So yes, they'll all be accessible after today, not necessarily literally, just purely from the video. Okay, so was everybody able to get something looking a lot like this green list showing up? Okay, great. So now we're going to be like, oh my gosh, like maybe it was sorted for, but let's be sure. So we're going to just go right in between that open parentheses and the D at the beginning, and we're going to type LEN open parentheses. And then right at the end of after the closing parentheses and unique and the last parentheses, or actually you could just go all the way to the end. We're going to add one more closed parentheses. And then we're going to run it again. Nah. Or you can just change your line. Sort of like you do when you're building an Excel formula. Oh, I guess I did say to put it on a new line, but I don't think it matters. I think we're going to comment it all out anyway soon. Do I need to pull up old code? Oh, yeah. So does everybody have 4 on their screen now when they hit run? Okay. So we just wrapped something between the print and the df3.unique. So some useful things to wrap around it are LEN. It'll give you a count, because like, what if there's 4,000 of them? You really aren't going to eyeball that. List, when you want to copy and paste it to your clipboard, or it can be really nice to actually get commas between those quotes. Probably doesn't help when your data also has commas in it because it's a bunch of addresses, but it helps a little bit with the eye fry. Sorted is another one that's nice. It produces a list as well with commas, but they're in case-sensitive alphabetical order. And then sorted put your thing, and then before you close out the parentheses from sorted, add a comma and add a space, and add key equals str.lower. I'm not going to say why that works, it just does. And the documentation says it does. And that will make sure that it's case insensitive when you sort. All right, so we're going to comment out those 2 lines that we just took the time to add, or if you just changed your first line to do the second exercise, just comment out 1 line. So we'll just put a hash at the beginning of the lines of code. And we're going to type in 3 new lines of code at the end of our program and run it. I should actually be doing this so that it gets into the recording. Well, that's awkward to do while you guys are trying to watch it, isn't it? All right, I'll do it when everybody's done. And each of those 3 lines are pretty much just building on the last one. And I tried to highlight what was special in blue. Like what changed from one line to the next.
You put those spaces at the beginning when you were writing this yourself, and you put that for our use of our eye.
Ease of your eyes. And that's just centered, sorry, and they're getting longer. Yeah, maybe I should just make that a left justified indent in a revision. Thanks. Have anybody gotten it to run yet?
So we tried before, and then we found that if you add the df3 SCP equals it displays as a column as a list. I'll then insert everything into here, so I just show unique addresses. So all double dot.
Well, first of all, you wouldn't want to do it inside of length because that's just a 4.
Oh no, yeah.
You can't.
I was just counting how many.
Okay. Okay, so if you wanted to do the unique ones.
Right, let's display them in table.
Let's see.
And that was what I googled.
Let's see if we can. So that whole like, what?
And that's what I thought.
Let's see if it works. It's gonna work. That didn't work. Well, so if we. Yeah. You're gonna want to Google either how to put a separator into those or how to convert them into something that is easier to put a separator into. Just for the chat room, we had someone asking a little bit of an advanced question about if they wanted to print the 4 unique addresses on different lines, what some tricks they could Google might be. And I don't actually know the answer to that question off the top of my head. Hey. Oh, Visual Studio Code.
Yeah.
Okay. Are you? Oh, and you got it to run on your computer already. So you're running you downloaded my CSV file, or no? Actually, I suppose they're all pointing to the web anyway. So you're running this stuff on your hard drive instead of in CodeBunk. Nice. All right. So has everyone gotten it to run? No. Okay. What's going on? Is a lot to type? Oh, well, let's figure that out. Okay. Usually it's the first one and the last one. Key error, DOB. There needs to be a period after the B.
Oh.
Yeah. It's very picky about column heading spellings.
Got it.
Yeah.
Maybe that's it.
So somebody got an error, key error, DOB, and it was because there was a period missing from after the B, and it was like a really, really long error message. And when you get a really, really long error message in Python, usually the thing that will actually help you figure out what's going on is at the top of the error message or at the bottom of the error message. Usually not in the middle.
And sometimes it won't help you at all. That's why it does help to have people to Google sometimes.
Yeah. Okay, so has everybody gotten this running? So what we did was we tried a new command. We had done unique, now we're doing drop duplicates, and let me put that all up and pull it up on the screen. And I didn't really, if you just put empty print between commands, you can get a line break. I'm gonna do that so that you guys can really see what I'm talking about. So with just drop duplicates based on address, keep equals false. We've got two things going on here. First of all, we said that our matching key for whether something is a duplicate is that they're at the same address. And then there are three options for the keep command. There is first with a lowercase f inside of quotes, last with a lowercase l inside of quotes. And what those will do is they will go ahead and, like when you say drop duplicates, it's more like what you think of when you say drop duplicates. You don't usually mean like drop everybody who is a duplicate. You mean like, no, give me one person that address and drop everybody else. So that's how those first and last things, they're kind of more what you would think of as drop duplicates. But you can also say, look, if somebody lives with anybody else, like drop them all. Drop anybody who's living as a family. Like, I want to see just people who live alone. So drop them. Yeah. So there's only one person in our data set who wasn't living with somebody else. We wanted to see, so that happened to be row number 8, which is actually the 9th row of our original spreadsheet and would be showing on line 10 if it were Excel. Yeah, because we start with 0 here. And then all we did was surround that with the LEN, because if we had a much bigger data set, we wouldn't be able to eyeball it. And we can see there's one row that survived that operation. And if we then instead wanted to see, well, what if instead of like saying we want to see only people who live alone, we want to see people who, we want to see how many people don't live with a twin. So we had 9 people in our original data set, and we say match on address and date of birth, and drop anybody who does live with their twin. So we had the 2 twins who lived together, and so 9 minus 2 is 7. So that's what's going on there. Okay, hashtag yes, I like this. Retweet, hashtag yes. Okay, so one thing you might notice is that we did that on 3 separate lines, and we just kept over and over again typing df3, do something else. Like, we had gone all the way down to row 8, and yet we were able to do it again with a different definition and get, 7. So we didn't actually like change anything about what was stored in that variable df3. We were just like displaying copies of it. All these things that we've done so far, all the commands that we've been using so far, they just display copies. And so far we've read a CSV file off the World Wide Web into our program. If we had changed what was between the quotes, it could have been off of our hard drive. We've displayed it on the screen, and we've displayed just a snippet of how it begins or a snippet of how it ends. We have counted a lot of things with LEN. We've counted number of values in a list from unique. We've counted numbers of rows in an output table that was a copy of, we've transformed it and made a new output table, and we want to know how many rows are in it. We have combined those things, to count useful information. And we have also been able to say, well, I don't want to know just how many unique data rows there are. I want to actually see them. I want them to be part of my new table that I care about. And so we've looked at this drop duplicates command. And as I mentioned, you can also decide maybe you will just want like head of household, and you're going to, maybe first you're going to sort everybody by how old they are, and then you'll drop duplicates with keep equals first. So if you put a variable or some other expression inside the little dot, dot, dot here of print type, and it gives you this about Pandas data frame, then that dot, dot, dot is an expression, and .2_CSV or .2_Excel will work on it. And the .2CSV command itself is already kind of long. So although you could take this dfc duplicates, etc., that's inside the print, and just keep on typing .2CSV after it, I don't recommend it, because when you have to go back and read your code in a year, you're going to be like, what? So, oh, this should not have said print. That's bad. I got to fix that right now. So we're going to take our copy with the dropped duplicates. We're going to save it off. I like to call it output df when I'm all done at the end of my thing. And we're going to say output df .2CSV. And when that second line of code runs, that's what actually saves the CSV file to our hard drive. But we're not going to do that today because we're running code online and we have nowhere to save it. All right, we're going to do more lecture. So a data frame, as we've seen, is table shaped. Comes with Pandas, doesn't come with Python, but most of the time when you install a Python IDE these days, it'll come with Pandas because data science is huge and everybody wants to do stuff. A series we haven't really gotten into yet, but a series is just a row or a column of data as Pandas looks at it. And then a list is the idea of a list in Python. And things that you can do is you can when you're just selecting submembers on a list or a series, you're selecting cells, or on a list I'll usually try to call them items, but cells, items, it's kind of the same idea. I guess it just depends on whether in your mind it's like, if it's a plain old list like that list of addresses, that's not so much a cell anymore. That's like a conceptual item in the list of addresses. You might think of it as a cell if you're thinking of your data still as a table though. If it's two-dimensional data, you can like select, like I want like the second column and the fourth column and the seventh column. Or you can say like I want the third column and the fifth column. You can select entire lists and lists themselves. In one-dimensional data, you sort things. That's pretty simple. It's just like rearrange them. In two-dimensional data, what you're doing usually is sorting the rows, but you're using the columns to define how you want to sort them. Other things that you often can do to two-dimensional data, an entire table at a time. You can add a column, you can drop a column, you can put them in a different order, you can rename a column label, you can import the entire table from a file, you can export it out to a file. More list-oriented things that you do, and again, this is going back to the whole like, well, what can I do to it? Can I divide this by that? You know, not so much, but here's some neat things you can do to a list when data is a list. You can edit the items in that list based on stuff you find in corresponding items from another list of the same length, which is sort of like, you know, when you do like, when you're in Excel and you go over to a blank column and you say equals E2 plus 5. That's what you're doing. It's just that instead of doing it cell by cell, we can do this, we more define like at the list. It's almost like if instead of doing that and having to copy down that formula in all the cells, you could like right click on the number or the letter above the column in Excel and be like, this is the definition of this column. This is the formula column. little bit more like defining a formula field in Salesforce. And then other things that you can do to lists of data is you can decide that you want to do a certain zero-dimensional thing like addition or division or whatever, but on all of the items in that list. So you might check for each item in this list, does it start with Z? You might check for each item in this list, is it less than 10? For each item in this list, add 3 to it. For each item in this list, check if it's in some other list. For each item in this list, tell me if it's blank or not. So programming is really working blind. You know, you're not going to like just give it a try in one cell and be like, yeah, that's what I wanted to do, and copy it down. It's going to be more like you do it and you're going to print it and you're going to see all your errors for the entire column all at the same time. The head thing can be nice because, you know, that head thing also is applicable to columns. And so you can say, just show me the first 2 cells of that column because I'm not even sure I wrote this correctly. But when stuck, just it's helpful to be able to break those problems apart and really think like, what kind of data am I trying to do this to? Where do I want to put the addition? I want to put that like in the part where I'm saying do this to every cell of this list, because you don't add a list, you add the items in a list, as opposed to the definition of please go over the items in this list and repeat everything for this list. That's like a thing I do to the list. Does that make sense? Okay, good. So those numbers that we've been seeing to the left of our data that start with 0, those are called row indexes. And columns also get indexes. They don't show up to the left of every column, but they're there. And they're kind of like row numbering, and they're used when Pandas does a lot of its column-to-column comparison logic, sort of like Excel. You know, it's like E2, you're probably going to type F2 on the next line. You're going to usually line things up, but Pandas does a lot of sort of auto-lining things up for you. And it's almost maybe better to think of it as a row ID than a row number, because Pandas isn't going to, I am stepping in front of the screen. Pandas is not going to care if it's just rows 0, 2, 6, and 7. It's still going to say, no, that's a 4-row table. It doesn't care if it's 3, 0, 1, or 2, 1 and 2, because you've sorted it. It's going to leave those row IDs with their row unless you do special commands to reset the index. And it's going to say, that's cool, that's a 4-row table too. It doesn't actually need these things. So it's probably best to think of them as row IDs. There are named row IDs. One of the things is maybe you want to take like your 18-digit Salesforce ID out of the ID column and treat it as the row ID. I don't really find that necessary. Sort of like you can have your Salesforce ID and an external ID, and you can, it doesn't hurt that they're both unique and they're both there at the same time. I don't think it hurts to just let Pandas give everything numbers from 0 through whatever. There are ways to make your data the row ID, for example. And so it doesn't have to be 0 through whatever. When you do advanced pivoting and grouping, the row IDs can really start to get weird. And technically, the column names are also, those are column IDs. So that's why we keep having to type them like really, really carefully. But a lot of things just sort of run on this idea of item number. So one thing I wanted to show you is how to recognize these 3 types of data that I've been talking about. The absolute proof. If I ask you, how would you prove what type of data this is? I want the answer to be, put it inside of print type. That's how you're always going to know what it really is. But visually, the 3 main ways that a data frame will look like. Number 1, it's going to be able to have more than 1 column. It might coincidentally only have 1 column. That's okay. It can still be a data frame and just have the 1 column. But the idea is that it's allowed to have multiple columns. It's inherently table shaped. When you put it inside of print, nothing displays below the last row of data. When you print just a single column, there's junk that will display. It'll still have some sort of row ID to the left, and that will be left aligned, and it will not have a label for that row ID unless you turned some of your data into that row ID, in which case that will be like on an extra line below the column headers. Again, might be out of order, but Pandas doesn't care. And because, you know, we moved Donald to the top because Duck is the first in the alphabet. So that, did I get it? Yeah, so the column names are as high as they can go, right aligned over their data. And the row IDs are at the far left. They're left aligned, and their label is lower than the column names. A series can look similar, especially it can really look similar to a single column data frame. But you will have some sort of junk at the end, giving you a little bit of information about what is in that series. And sometimes it won't necessarily always have the name. It'll usually have a data type. It'll usually just say object, which is very useful. But sometimes it'll say Boolean, which is useful, because you'll be sure that it's trues and falses. There's bool. It won't put anything over the top of the data. That's a big giveaway, is that basically if there even is a name anymore, sometimes you do stuff that gets rid of it, but it starts with the data, no column name. But it does still show your row IDs. And these are all examples of series or lists. Fancy stylized lists is basically what a series is, that came out of asking for a column. But we can also say we want row number 2. And in that case, you can see that the item IDs of this row series are the column names. And then you have like each cell value from that. So any questions about that? Okay, and again, the proof is to put it inside print type. And hey, it says Pandas series. So yeah, they're inherently one-dimensional. This doesn't count as a column. And the row IDs are still at the far left and does have a thing below hand. Lists look way simpler. They don't even have this circle. That's a bullet point. They just start in brackets. They're comma separated. They're inherently one-dimensional, but you're not going to. They actually do have item IDs, just like series do, but it just 0, 1, 2, 3, 4. They just start at 0 and go to the end, counting by 1. So we are going to open a new code bunk, link.stthomas.edu/sfpy123. And I've got that up at the top. I just made the big part of it smaller. So we're going to do some code that combines data from our first name column and our last name column on the first spreadsheet. And we're going to compute initials. It's like making a formula field. How are things coming along with getting the code to run? All right. That's cool. We're doing kind of a brute force approach to computing initials here. Anybody who's tried to do that in a formula field would possibly have run into the idea of, well, what if they don't have a first name? Do I still put the period and the space in between? So there's definitely a lot more complex you can get with the code, just like you could in an Excel or a formula field about trying to make sure that there is data before you add the punctuation. We're not going to do that in this example. We're just going to presume everybody's got both. So I'm going to start asking some questions while people are still typing. These SCR1 first, SCR1 last, SCR1 initials on the left side of the equals, those are all variable names that I'm using so that I can refer to them later in code by their nickname. What data type do you guys think I'm putting in there of the ones we've talked about so far? Any other guesses? No. But when we print the last one, it prints out looking like the green stuff. Yes, a series. All three of those are different series typed data. So what would be your, how would I prove that SEER1 initials is a series? Yay, yes, print type. And is there any other rationale for why you felt like it was a series before you even?
It's in the list, so it's going to have the one column. It's going to have the one column, row ID, and that's fine.
Yeah, one column, row ID, row ID. At a glance, it sort of looks like those examples we looked at. I don't know. Would you guys have wanted to name them something different, maybe? What would you have preferred?
Well, I mean, it's nice to have the type in there. So later.
Okay,
Like,
so
I don't have an argument.
first initial might have been good enough, might not have actually literally needed to type SER to remind yourself that it's a series. Okay. So then if we were to add a fifth line of code, print parentheses, actually, sorry, does anybody have any thoughts about whether the code even had to be 4 lines long in the first place? And if there's a way we could have shortened it up?
Well, you could probably put a print around 0 first plus.
Put a print around, just instead of saving it off to SEER1 initials, just put a print around that whole thing. Yeah. Anybody have any ideas of a way we can make it all 1 line? How could we have done that? Not use variables at all. Just type everything and don't stop. Yep, that's true. So it's a matter of readability. That would be ugly, especially in a year when you don't remember what you did.
Yeah. It can also be really error prone too, where you're not exactly sure which portion of the spread you've got on.
Yeah, just like Excel formulas can get nasty the longer they get. So that's one nice thing about programming languages is that unlike with Excel formulas, you get to like checkpoint your work. So if we added print and then the original data frame that we were pulling all this data from and constructing this initials from, do you think that it would be any different yet? Would it actually have a column with initials? You're saying no. Anybody want to say yes? Okay, anybody want to just try it and see if it does? Add a fifth line, say print df1. It doesn't. Okay, so yeah, we haven't actually done anything yet that is a command to change df1. All right, so we'll go on to the next one. Yeah, okay, so we're going to backspace out that final print, the series initials, and we're going to add 3 new lines of code. The main reason we're backspacing out the print from our previous exercise is just so that when we do this exercise, we won't have to read a lot of junk. Like, we already read it. We've seen it before. We could also comment it out if you prefer. That car is putting a lot of sun in my eyes.
Okay. If anybody is thinking about getting an ID on their computer, one thing that the examples actually really highlight that's nice in certain IDs is autofill. If you already typed something in previously in your script, it'll give you suggestions. That makes coding a lot easier and allows zero growth.
So I'm going to talk a little bit about the code while people are typing. On the first line of it, we take that series 1 initials that we defined earlier, and we make a copy of it that is sorted using the sort values command, and we save that copy into ser1 init sort. And we're going to look at it. And then the third line of code is we're going to put the keyword df1 for our data frame, and we're going to put the word initials in quotes in square brackets, and we're going to put that on the left side of an equals. And equals is funny in programming languages. Equals, when you're programming, almost never means is the same as. It means save it here. You usually use double equals in programming languages to mean, are these the same as each other? Just so you know. It's a little different than in Excel, where most of the formulas, you're not ever actually saving anything into anything else. So they can get away with just if something equals something with a single equals. And so what we're actually seeing as our output is the result of our second line that we typed. So is everybody seeing this? So we added a new initials column to the data frame, but what we actually set it to equal is, you know, AH, AS, blah, blah, blah. And if people remember, like, we had Jimmy Buffett on line 1 of DF1, but we've got AH as like the first thing in our series. So if we were to do print DF1 right now, I want to hear what people guess. Would we come out with, you know, in our new column, would we come out with AH on the first line, or would we come out with JB on the first line? We've got to vote for JB. We have any votes for AH? You got to vote for AH. Okay, people want to try it? All right, so what do we actually get? All right, so the reason that worked is because of that magic of, even though our data said that AH was like on the quote first line, it still had its ID of 6. And so when we did that magic of saying, I want to take this thing that's in the box that we put the reference to on the right-hand side of the equals, and I want to add it to DF1 as a new column initials, it knew to correspond the row IDs to the series IDs by their actual IDs. And so we ended up with JB correctly on line 1, and AH is way down on line 7. So now we're going to mess it up. Backspace out anything that starts with print so that it doesn't show up. And then at the end of the program, add these 3 lines of code. Yeah. No, that stands for initials sorted. The insert is actually when we do df1 bracket initials equals. It does. Yep. Correct. Yes. df1 initials equals blah 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 says create a new column initials and fill it in with the stuff on the right hand side of the equals.
The nice thing about Pandas is that it's built in to know that it's adding in the column they want values.
That is a really good explanation. I'm going to repeat that from Mike. The nice thing about Pandas is that it knows that if it's dealing with a column and you fill it in with values, they should go up and down. Yeah, this is where Python really starts to get powerful. Is a lot of these things that you would have had to very explicitly specify in an Excel macro. It's sort of like, duh. All right, so what we've done here is we've taken our sorted initials series and we've put list around it and we've saved that into a variable. And remember, lists, they do have item numbers and they always start with 0. You don't even see them because it's just so self-explanatory to start with 0. That's just part of what they are. This is a plain Python list. And now we're going to put df1 initials equals that list. Now, you may have all left the old df1 initials equals in your code, and that's okay. What it's going to do is the first time it does it, it's going to add that column. And then the second time it runs over your new line of code, it's just going to replace the values in that column. So we're just going to overwrite our old work, even though we didn't comment it out. And on the third line, I've got you taking a look at what it is that we just added to the initials column. And I want everybody to guess whether we're going to get JB or AH on line 1 if we were to add a fourth one that said print df1. We have any guesses? We do on the second line. We do write to df1 on the second line. Okay. Yeah.
A nice way to check the last value of the array or the list. As you have your list one in the SRT, and then square brackets -1.
-1. Okay, yeah. Just a tidbit someone pointed out in the back of the room is lists have a native way to just look at one item of them. You can put the item number of the, you can put an item number that hopefully is within the list. Like if it's a 7-item list, don't go above 6 because again, I'm counting from 0. And you can just see that one item if you put it in square brackets right after the name of the list. And then there's also a clever trick where since no list has negative numbers in it, the item -1 is always the last item in the list. So I'm going to show the output from df1, and as you can see, we botched the order. We now have Jimmy Buffett with the initials AH because we sorted it and then we stripped out AH's association with the number 6 by turning it into a list that starts with 1. So the takeaway from this is that series and lists are a lot alike, but not always. So sometimes it's nice, you know, they're very much alike. You can do, like if you need to do, they can both be put inside an is in command, you know, so that you can check if something is in something else. And they'll pretty much behave the same way there. But when you try to use them to write the data, you can really start messing around with stuff. But we never actually used the toCSV operation, so we're fine. It's okay that we mess stuff up. We can just backspace it out and write better code. And that is how I write all of my code. And so that's my, again, reiteration of don't write the same thing that you read from. So questions? Yeah.
So what did we try to say? That a series just a list, but with unique identifiers.
So the question was, this might be an oversimplification, but is a series just a list, but with the unique identifiers kept with the data they came from? I would say yes, for all practical purposes. When you get way more advanced, there are more impressive things you can do. They also have different commands available to them than lists do. They probably have a bigger range of commands available to them than lists do. Yeah. But for all practical purposes, they're just a souped up list. Yeah, good question. All right, so the biggest issue is that I said this would go from 11:30 to 2, and it's 2:10. So there's, yeah. Well, so Randy told me that there's a half hour of networking time at the end of these. You guys want to just get through as many slides as we can? Okay. All right. Let me just check where we're at, because I know there's like a ton of slides. Okay, we're sorting. Oh, I wanted to show you all sorts of stuff. Okay, this sorting shouldn't take too much longer. And then I have a whole bunch of filtering. That's not going to happen. Okay, I'm going to like sort of go out of order because I want to show you guys. Yeah, I'll rush through stuff after. I'll go through it in order, but then rush through stuff. The whole thing, even the stuff we don't get to. Yep. All right, so stay where you are, and you can just get rid of all the code we just wrote. Just leave the part above the don't touch this line. And then we have 2 new lines of code that we're going to add. df3 sorted equals df3 dot sort values by date of birth, ascending equals true. And our second line, we're pretty much just going to print df3 sorted, but because I needed it to fit on this slide, I only wanted to show 3 columns we care about. And so I'm introducing to you yet a new operation, which is that after any data frame, you can put double square brackets, the inner square bracket of which is a list of column names that you actually want to see. And or the list of column names that you actually want to have, because you could take this df3 sorted first, last, and date of birth, save it into output df, and then do output df.toCSV. Maybe literally the thing that would save you 20 minutes a day is to just have a script that, for example, looks for, columns that are these 3 names and throws away all of the other data and gives you your data set as a new CSV with just those 3 columns. That literally might be the thing that's useful to you. Because, for example, maybe you have data where you know what the column names are going to be. You know it's always going to be first, last, date of birth, but they might show up in various orders because they're coming from different databases. And one day, first name is in column B, and another day it's in column F, and somebody messed with it and sent it to you again. And so what you want to do is strip them by name. And so you just want to say, I don't care about all your other stuff. I just want the first and last and date of birth out of this CSV file you gave me. You can have basically a 2-line script that just imports the CSV and exports those 3 columns from it. So that's what this syntax is all about after that df3 sorted. Any data frame with that double bracket notation and a list of column names will give you a copy of the data frame, but just those columns. All right, so looking at this output data, have we actually sorted people from oldest to youngest? No. What did we sort them on? I'll give you a hint. They are sorted on DOB, but they're not sorted by when the date is. Yeah, they're sorted as the text of the date of birth. Yeah. So 1 0 comes before 1 1, 1 1 comes before 1 2, which comes before 8, which comes before 9.
That sorted list and you're picking a column.
Mhm.
You're not really sorting.
Yeah, no, the first and the last is not part of the sorting key, it's part of the display output. We're not treating it as a date. Yep. So there are 2 approaches to fix that. Number 1 is you can actually just tell the read CSV command to interpret it as a date. That gets troublesome in Salesforce specifically because when you're exporting and importing, Salesforce has a very specific timestamp format. You know, it usually wants it like in general military time with a very specific spelling. Other things can get really messed up with your time zone that you've got your org on. So that's not always a great idea when it comes to this kind of stuff, because then you probably have to convert it back into however it was. The other thing you can do is you can basically just add a column that is a new column where the date is an actual date, and then just exclude it from your final output. That can be really nice when you're dealing with Salesforce dates and you just need to sort of have some extra stuff to do your math on and then get rid of it. It's more lines of code, but can be handy in Salesforce. You don't always actually need a date to be interpreted as a date. As you saw before when we excluded the twins, like a date interpreted as text that's spelled the same way as a date interpreted as text, it'll still group just fine. So it's only really when you're sorting or doing any sort of comparison do you actually need to do anything special to dates. So we're going to fix this. And that part where it said don't change the code above this line, we're going to go above the line and change the code. The one where it says the DF3 Pandas read CSV, we're going to go right before the final parenthesis. No, sorry. Actually, right after the word, yeah, right before the final parentheses, after the word object. And we are going to add comma, space, parse underscore dates equals, and then we're going to put date of birth in quotes. And so this is that first thing where we tell Pandas, you know, when you read in the CSV file, treat this column as a date. And then we'll run our code. People do it, and people get it to run? Okay, great. So you can see what I was talking about, how it changed the way the date is printed on us. And if that mattered to us, we might actually consider that an improvement. And then when we write it back out to a new CSV file, we're like, great, I didn't have to worry about that. But if we actually wanted it in its original format, it could be a problem. So yeah, now we have people born in 1955 at the top and people born in 2010 at the bottom. All right, so has anybody, so as I said, sometimes like these things aren't really stuff that you couldn't do in Excel by clicking sort. So I'm not sure if anybody's actually even seen anything that they're going to take home and be like, I could actually save some time on that. But I'm curious, like, has anybody seen anything yet today that seems worth doing with Python?
Like I see the template for future sessions. Or I want to take more of these operations and string them together, write things, and you know.
Okay, putting these together with more advanced things. Yeah.
Yeah, we have, so at the media station, we have events, and like the state fair is an example. So we'll get a list of people that invited to the state fair. And then the spreadsheets we get back is that Judy Johnson attended, but she brought 4 kids with her. And what we'll get back is Judy Johnson attended, Judy Johnson attended, Judy Johnson attended. And then she might have been invited several days ago. Judy Johnson attended Judy Johnson. So it's not parsed at all. It's just raw data. Judy Johnson attended 8 times.
Okay.
Based on the fact that she brought in 4 of her kids twice.
Wow.
And we have multiple of these types of events, and so it becomes this mind-numbing challenge for us to do and crunch all this data out and say, no, let's just say that the Judy Johnson family attended this event. We know that she brought her kids. It's not a big deal, but just that we recognize that she came and put that in her file.
Okay.
And what we've seen here with the duplicate. Just show unique records, that would be huge for us. So I'd love to see more of that data manipulation here with the lifestyle.
Chocolate, office supplies, or t-shirt or sweatshirt?
Yeah, is it office supplies would probably be
Okay, I got the stab it to open it. This pen not only is purple, it writes St. Thomas purple. It's pretty cool for taking notes, making them stick out. You're welcome. Thanks for sharing. Yeah, so we had someone, for those online who may not have been able to hear from the audience, someone who literally actually has a system that just needs the unique and drop duplicates filter, because every time a person brings their kids and they scan their badge and say, and they brought 4 kids, they literally just show up 4 times in a row in the output data. And so that is awesome. And yeah, we got transforming it without human involvement. If you get the same kind of data a lot, you only have to solve the problem once. Awesome. Yeah, I'm going to hurry through this. I think I'm gonna just mention. All right, so you saw us do some stuff like take a data frame and then put a column name, or take a data frame and put a list of column names. They behave a little bit differently. Just the single column name produces a series. You saw that when we were concatenating df1 first and df1 last into initials. Each of those were a series. But then when we did the final output and we said we wanted to see first, last, and the other one, the output was a data frame. This is really useful for peeking at tables that are very wide and would scroll off your screen, just like head is for tables that are very long. And so they look the same, but when you put a string versus a list inside of them, they behave differently. There's also special behavior on the left-hand side of an equals, an assignment equals in Python. And so if you take one of those series ones, df1 first, and you set it to initial, everybody will have that first name. Which is actually really useful when you're adding campaign IDs to contact lists. So we did that idea. If there is no column name first, it'll add it, which is what we did with initials. So you can put something simple on the right side of the equals, or you can put something with the same number of values. If you put df1 first, and then you try to put like just a list that's only got 2 things, but you have 5 rows in your database, it'll yell at you and error out. But either one thing or a list of 5 things will work great, or a series that's 5 things long with like the same row IDs. Double bracket notation is similar, although it won't add things that don't exist. If you need to add multiple columns that don't yet exist and then you want to fill them in later, I typically recommend you just 1 line per column and just put none on the other side and then actually fill them in later. And so then once they exist, df1 double bracket first last equals a list of names. As long as that list is the same length as the number of columns you specified, that'll work, and it'll just turn everybody into an Anush Lopez. You can also just put a single thing there and it'll apply it to every column. So you'll have some Kelly Kellys. Yeah, You probably don't want that many Kellys. That probably has nothing to do with your real world data set. Okay. I want to hear about this data set that needs Kellys in it. So let's see. We did this in our, we talked again about like, well, we could have done that in a one-liner. So again, if we wanted sort of a concatenated full name, you know, you've got a series of df1 is last. You have just a single item. That's sort of that thing of making everybody a niche, you know, but what you're saying is concatenate that row by row, cell by cell, you know, with the other thing, and then cell by cell with the third thing, and then save it off into this other series that doesn't even exist yet, but now it can. So you're building that game of how many expressions are there? Here's an expression, here's an expression, here's an expression. df1 last, comma, first. Those are all expressions. The whole thing on the right side of the equals is another expression that's also a series, which means then that you can save it off into a new series that will be appended to df1 because that's the way that bracket notation works. Full is a modification one. Last and first are just like, they give you copies. They don't do anything. Does that make sense, everybody?
Yeah, so you're saying full and last and first are kind of.
They're different.
Like reserved words. They're not.
No, they're not actually. They're just names. Sorry, they're column names. Yeah, but they're behaving differently because they're on different sides of the equals. Okay, adding empty columns to fill in later. Like I said, just put a data frame, say which column name, put none. None is the null value in Python. When you're looking at your output, sometimes you'll see NaN and sometimes you'll see none, but they both reply true to an isNull check, and they both write blank to your CSV. So it really, other than you'd be like, wait, that says one thing and that says another thing. When you're like looking at it in your print statements, it doesn't actually matter. So renaming a column, you just say the data frame, and then you say dot rename, and then you say columns equals, and you give it a curly brace. This is called a map, and it's the old name, colon, the new name, comma, the old name, colon, new name, and you can go comma as many of those as you have columns that you need to rename. And that gives you a new copy of data frame. It does not change data frame. It gives you a new copy that's just like it, only with different column names. But there is a way to do it. And there's the one you'll often see is you just take that thing that doesn't actually change anything, and you put it on the right side of an equals of the exact same variable name. And that's a weird thing. That's like saying, you know, like x equals x plus 1. You can't do that in algebra class, but you can in programming, because what it actually means is compute everything on the right and then overwrite the old thing with the new value. The other thing that is equivalent to that is you just write the thing that you wrote up there, but you, right before the final close parentheses, you write comma in place equals true. By default, everything is in place equals false. Comma in place equals true will make it as if you had written it this way. So they both work. We're getting a couple questions. Okay, can we use this with Google Sheets? That is a really good question. I'm guessing there's probably a package to actually do it rather than just pointing the URL of a Google Sheet, but I don't know.
I think it's probably just a certain command you have to learn with Pandas that will interpret Google Sheets as a regular spreadsheet.
Okay, it might not be just read Excel.
Yeah.
There's a package? And what, does it read it as a Pandas data frame? Okay. So save your data frame onto variable, and then PyG Sheets has commands to write a data frame back over your spreadsheet, Google Sheet, or a new one. Again, be careful overwriting real files.
You have to battle with a lot of Python packages of getting your data into the right format.
Yeah.
Still use the package on it.
Yeah. There are also, maybe you just you know, we pulled out like first name, last name, date of birth. Maybe it's more like, no, I want to see everything unless it's one of these columns I don't like. And so there's a dot drop, columns equals, and then you put just a simple list of column names in there. Again, there's the in place equals true, or the save it over itself, if you actually want to change your data frame. Otherwise, if you don't do one of these at the bottom, future references to that your data frame variable will have it with the column names that you just dropped. You won't really have dropped them. The top one makes a copy. Older versions of Python don't do that. They have a different syntax that you can look at the slides later to see. But if it doesn't work, not necessarily because you typed it wrong. It might be because you have an older version of Python and Pandas. So expressions and statements, they can kind of get all mixed up with each other with just a small bit of code. And your eyes might glaze over and you might not notice, and then you're wondering why it doesn't work. So keep calm and expect your data types, and don't overwrite your code so that you can say oops. Every series, like df1 last, there are like so many operations that start with dot whatever, like hundreds. So like str0, that was one we used to grab the first letter of something. That means grab the first letter of it, presuming it's actually text. It'll error out if it's not text. Some of them are things like max, but typically they will produce a new series that's a copy of your series, but new and improved. And I have been trying to make a short list at that third link, but this first link is literally it's the official documentation, and it's very long. There's dozens just for manipulating text. But the most useful ones are the ones that when they give you that copy of the series, only new and improved, the output is true and false, because there is a special syntax. Why do I always, okay. I'll show you later. When you take a true and false series and you put it inside the brackets of a data frame, it filters the rows. And it gives you a new copy of your data frame that only has the rows where that condition was true. So that's why that's useful. So now we're going to, we're not going to get to that exercise, but I just wanted to give you this. I think actually a better way to show that is to show you this filter, where first thing I did was I said, okay, df1 last, that's the last name of everybody, and I'm going to save it off into a series called last name series. And then I'm going to take last name series, and I'm going to do one of its dozens of string text processing operations, and I'm going to check if it starts with a capital C. And I'm also going to take another copy of last name series, and I'm going to check if it starts with a capital S. And then I'm going to take those two copies of yes and no answers, and I'm going to AND them together row by row. And the way that works is, I'm going to OR them. That's what the pipe is. And so it's just, it's like, well, if line 1 and line 1, if either one of them is true, then the final output yes, no series, that row will be true. And so this is, does last name start with C or S? It's a big old true and false series. Then I'm going to put that inside brackets next to df1. Why is there no output? Oh yeah, because I have it down here. And then I'm going to put that into a CSV file. And what I get is I've effectively crossed out people whose last names don't start with a C or an S. And so I had this cool exercise where we were going to make one together. But I think, let's see. There is, don't always need to actually do that, like, let's see, where was I? So but you don't always need to do those operations against a series. There is one in particular that's useful that you do against an entire table at once. And that's the duplicated one. So you put in df3 and you say dot duplicated and you say by what. And then again, we have that whole like heap thing with false first and last. But we're going to go with false right now, which to me really kind of is the option that most matches the name of the function. And we're just going to say based on address and date of birth, rows 7 and 8, twins. Those are the people who are duplicated within our thing. And so we've just got a list of row IDs and whether those row IDs have a twinsy somewhere else in the data set. And we can, and that particular thing that's inside of our print statement is a series that's true, false. Wow, I just hit end. That was not good. And so if we, instead of printing it, save it into a series, and then put that true false series inside of df3 bracket notation, we actually get them as output. So this is really great for duplicate hunting. Another thing we can do is just check. We could have put that whole thing inside of, so who knows the power of one trick in Salesforce? You set things to be 1, and then you count them. You can set things to be 0, 1, and then just sum them. And so it turns out that trues and falses are actually considered 0s and 1s for certain operations. So we can take that whole thing and add it up, and that's our count. That's our duplicate rows count. So I want to show you guys. This is going to be in the slides for you. This is my gift. This script is something that I like to keep on hand, and so I import pandas. Don't really need to do this. But yeah, you can set that thing. And I'm going to say, this is my file name. And these are the columns on which I want to, that's my duplicate matching set of columns. And I just edit this every time I have something to inspect. And then I'm going to say, my df variable is pandas read CSV, this file. And I broke that up so that it'd be easier to edit. And I wouldn't have to go edit in the middle of this line. And then is dupe series. I'm going to do that whole, like, it's duplicated, and then I'm going to put the columns, put a reference to that column list there. And then I've got another one called is first dupe series, which that one, it actually shows up, let me think. So the 2 twins, only one of them would have been true. Only the first one would have been true. The other one would have been false, even though she had a twinsy. She wasn't the first twinsy in the list. And so what I'm going to then print to my system output is I'm going to say, okay, we had like 2 people who were duplicates in one group among 9 rows. That's just the whole length of the data frame. So we've got the sum of all people who had a twinsy in the sum of people who were a first twinsy in the length of the table. You guys follow me so far? Okay. And then you can say the duplicated rows are, and you can say data frame is dupe series. And you can say the duplicate keys are, and you can, this is a new syntax actually. You take your data frame is first dupe series. That is just the people who were a first twinsy. And that itself is a new data frame. But all data frames have a syntax where you can then put a list of columns right after them and say, I just want to see those columns. And so that's what we're doing is now we're taking our dupe columns and saying, but just show me the column, just show me those particular matching columns from the people who were the first twinsy in a set. And now you have, what that is it's a data frame of all of the unique keys that were found. So 5 useful things that you can quickly analyze about a spreadsheet. All right. I think that's good for today. And we'll get into more advanced stuff and merging and all that kind of stuff. Any questions? Thank you so much for coming, and I hope you'll come back to 102. Yeah, all right, it's great to see you. And Devani's is right behind this building at Grand and Cleveland if you're hungry. The Blue Door Pub makes really good Juicy Lucy's and is not too far from here. It's Selby and Fairview. Yeah, thanks, guys.